Hi guys, today we're going to be going over lesson 712, which is again about rules, tables, and graphs. This is that part 2, just an extension of yesterday's lesson. So this starts on page 270, so make sure you're on the correct page. And let's look at the math message. It says Carla earns $20 per hour. Write a rule that describes how much Carla earns. So think about that. What type of rule could you write? If she earns $20 per hour. So maybe we could say the number of hours that she works. So number of hours worked, we should put worked. Number of hours worked times 20 equals her earnings, right? Or how much money she gets. How much money she gets for working. So we could write, that would be a rule that would describe if Carla earns $20 per hour when she works. So now that we have our rule for this statement, we could use this rule to complete this table. So we're going to write ordered pairs to represent the data in the table. So if she works 1 hour, of course she's going to get $20, 2 hours, 40, and 3 hours, 60. So do you see any patterns that are happening in this table? As you're going down the X, you're adding 1. As you're going down the Y, you're adding 20. And you can see that corresponding relationship with the rule that we have here. All right, let's go ahead and write our order pairs that we're getting from the table. Okay, now does this problem, this math message, remind you of the math message we did, or the problem we did yesterday? I had you guys do it independently. So yesterday there was this problem about Andy earning $8 an hour, and then we have Carla earning $20 an hour. So we can see that they have a different rate for their hourly work. But what we can do, we've graphed Andy over here, and please, I apologize about this mark across the page. We're looking at this line that you drew yesterday. What we can do is we can use this tables and graph to compare situations. So sometimes there are two different rules that relate to two sets of corresponding terms. So like Carla's information could be one term, Andy's information could be a second term back on 266. And what I could do is I could take Carla's information here, and I could take that and plot a new line over here so I can compare Andy's to Carla's. So on mine, I have Andy's information in red. So I'm just going to write his names in red so I remember, or you could label it and say Andy's earnings. And what I'm going to do is I'm going to use the same coordinate grid to write Carla's earnings. Okay, so go ahead and plot your ordered pairs on the same grid that you did for Andy's earnings. I'm going to do that now as well, and then if you need more time, when I'm done, you can always pause the video. Make sure I was doing it. And again, if you have a straight edge, that's going to make it easier, or some type of ruler. And then go ahead and make a line through your points. Okay, so if you need more time, go ahead and pause the video. But that's what your two lines should look like. And if you were not able to use two different colors, then you could always label it up here. Like perhaps you could say Carla's earnings and Andy's earnings. That way you have the data correct. Okay, we know that it takes Carla 1 hour to earn $20. How many hours do you think it would take Andy to earn $20? Okay, we're going to look over here. Here's the earnings. We're going to go to 20. And we're going to go to Andy's line now. So how many hours do you think it would take for Andy to earn $20? Yeah, hopefully you said about 2.5. Okay, we saw that Carla can earn $40 in 2 hours. How many hours would it take Andy to earn $40? Okay, did you find that it was 5 when you go down the graph? 5 hours. So you could also see if it took Andy 2.5 hours to earn $20, 2.5 plus 2.5 is 5. So you can see that relationship there as well. Okay, here's another question. So you can also make that comparison between Andy and Carla, right? If it takes Carla 2 hours to earn $40, it's going to take Andy 5 hours to earn that $40. Okay, so if they both start work at 8 a.m., by what time will Andy have earned that $40? So if it takes him 5 hours and he started work at 8 a.m., at what time do you think he's going to earn that $40? If he starts work at 8 a.m. and he wants to earn that $40, what time will he have earned it if it takes him 5 hours? Okay, hopefully you're able to do 9, 10, 11, 12, and then 1 o'clock. So if Andy starts work at 8 a.m., he's going to have to work until 1 p.m. to get those $40. What about Carla? If Carla starts work at 8 a.m., at what time is she going to earn that $40? You remember how many hours it took her to earn 40? Right, hopefully you figured out that it would take her until 10 a.m. to get those $40. So then we could compare if they were both trying to earn $40 for the day and then that's all they needed and they could go home. Carla would be able to leave at 10 and Andy would have to be there until 1. All right, so this is the direction we're going with this lesson. We're just using tables and graphs to compare situations in which there's 2 different rules that relate to 2 sets of corresponding items. So for Andy's rule, for every 1 hour he worked, he earned $8. For Carla, every 1 hour she worked, she earned $20. So they have those 2 separate rules. And then we have those 2 corresponding terms or these corresponding information, and we can compare those. Okay, so that's another benefit of using these tables and graphs. All right, let's come back to page 270 now, and let's look at Eli and Lupita. And if you have 2 separate colored pencils or something, that might help kind of keep track of Eli and Lupita separately because we're going to grid some information that we get for them. So number 2 says, Eli is 10 years old and cannot run about, Eli is 10 years old and can run about 5 yards in 1 second. And so we have Eli over here. I can already pull out that important information that I'm going to have to use for this graph. Okay. His sister Lupita is 7 years old. And she can run about 4 yards in 1 second. So Lupita is 7, and she can run about 4 yards in 1 second. So I know that that's going to come over here to this table. Eli and Lupita have a 60-yard race. Because Lupita is younger, Eli gives her a 10-yard head start. We're going to complete the tables over here, showing the distance Eli and Lupita are from the starting line after 1 second, 2 seconds, 3 seconds, and so on. We're going to use the tables to complete problem 2. Okay, so lots of important information in here. let's first start with what I've highlighted up here. So Eli is about 5 yards in 1 second. So we've got the seconds marked. You can see the pattern here. For the yards, if he can run 5 yards in 1 second, well, then we're going to put 5. And then by the second yard, he's ran another 5. So do you see the pattern? As long as this is continuing to go by 1 every time, and they haven't skipped numbers, then we can count by 5 every time. So go ahead and fill in Eli's chart. Okay, whenever you're done, you can double up or double check, looking up and checking mine. Okay, now let's look at Lupita. Lupita can run about 4 yards in 1 second. Okay, now here is the difference. Do you see this part? It says because Lupita is younger, Eli is giving her a 10-yard head start. So if you look at the table for Lupita, you have at the start, she already has 10 yards because he's giving her that head start. After 1 second, though, she can run 4 yards. So where is she going to be here? She's going to be at 10 plus 4, which is 14. After 2 seconds, she'll be at 18 because we're going to add another 4. We don't need to continue to add 10, right? Because she just got that extra 10 at the start line. But every second she gets 4 yards further. So we're going to continue to add 4 all down this list. So just double check that this is adding by 1 each time. And then we're good to then add by 4 each time. If they had skipped a number, like if they went from 4 to 6 to 8, then that would be different, right? We'd have to use our rule of however her seconds are, and then plus 10 times 4, or times 4 plus 10. All right, but we're good to go. We can just go ahead and add by 4. So go ahead and add by 4 all down there, all down that column. And then when you're done, you can double check your numbers with mine and see if we match up. Okay, so it said to complete the table showing the distance Eli and Lupita are from the starting line after 1 second, 2 seconds, 3 seconds, and so on. We've done that part. Then it says to use the tables to complete problem 2. So remember, they have a 60-yard race. So you can see this is our yards in this column. Okay, distance in yards. So letter A says who wins the race. Well, who is getting to 60 first? So they both are starting at the start line. Who in this column gets to 60 first? Well, after 12 seconds, Eli's at that 60 finish line. And after 12 seconds, Lupita is at 58. So it looks like Eli is the winner. And I don't know why I wrote his name all in capital letters, but there we are. Okay, part B, how long does it take the winner to finish? Well, 60 yards took him 12 seconds. Letter C, though, says who was leading during most of the race. So who was in front? So let's compare. Okay, at 1 second, Eli was at 5, Lupita was at 14, 2, 10, 18, 15, 22. So far, Lupita's leading most of the time. At 4 seconds, Lupita's still leading. 5 seconds, she's still leading. 6 seconds, she's still in front. Even at 7 seconds, she still has more yards. She's still passing him. At 8 seconds, she's still ahead of him in the race. This 9 seconds, she's still ahead of him, but look how close they are. He's at 45 yards, she's at 46. At 10 seconds, they're even. Oh, this looks like to be a good finish for this race. 11 seconds, that's where he took the lead. So Lupita was ahead for 10 seconds. Well, at 10 seconds they were even, but for 9 out of 12 seconds, and just at that very end, Eli came in strong and got ahead of her and finished the race. Okay, but who was in the lead during most of the race? Lupita. Lupita was in the lead most of the race. Okay, so let's now, after we've understood this information in this table, we understand how the race went, let's write a rule. So let's start with Eli's rule. So coming from his in table to his out, we could say the number of seconds, right? Because that's your X. So the number of seconds times 5, right? Because he could go 5 yards in 1 second, times 5 equals his distance, which is what Y stands for. His distance. Okay, see if you can write a rule for Lupita. Go ahead and pause the video if you need to and write your rule for Lupita. Okay, did you find Lupita's rule as the number of seconds times 4, because she can do 4 yards in 1 second, equals her distance? Okay, so now you're seeing another way that we're using this table to make some comparisons between Lupita and her brother Eli. Let's continue on page 271. It says to write 4 ordered pairs from Eli's table and 4 ordered pairs from Lupita's table. So you can pick out any 4 from Eli, any 4 from Lupita, and you're going to write those down here. Then once you have your ordered pairs, you're going to graph Lupita's line and Eli's line. And then I want you to try to answer question number 6 using this graph, number 7, and number 8. See if you can explain how you figured it out, 6A and 6B. So you're going to do this entire page on your own independently, and then we'll go over answers when you're done, but that way you'll know if you're on track or not. So go ahead and pause the video now and try to do page 271, and I'll keep that there in case you need to see it. Okay. If you are unpausing the video, that means you are ready to go over some answers. So that's what we did together. Your ordered pairs might be different than what's shown, but as long as you got them off your table, that's fine. There's just some sample ones you could have had. But no matter what ordered pairs you picked, your lines should have looked the same. So Lupita is this solid line right here. You can tell she's leading most of the time, and then here at that 10-second mark, they're right even, and then Eli pulls ahead. Eli is this dotted line, okay? That way you can check your graph. So how many yards apart are Eli and Lupita at 7 seconds? So when you find the seconds at the bottom, you're going to go 7, and you can see Eli is right at 35. Lupita is somewhere between 37, 38. So 38 minus 35 is 3. That's how they figured that. If you put 2 yards, I certainly understand that too. But 3 would be the most appropriate answer there. Okay, suppose Eli and Lupita race 75 yards instead of 60. Who would you expect to win? Well, Eli would be the person you would expect to win just because he's already gaining on her and he can do 5 yards in 1 second, whereas Lupita can only do 4 yards in 1 second. So you can see him taking the lead and he can get more yards in 1 second. So I would expect him to go ahead and finish and win the race. So how long would it take the winner to finish? So if it was 75 yards, the way you could figure that out is you could come over here to your 75 yards if that was the race. I would expect Eli to finish. So his is that dotted line on my graph. I could see where he's at 75 and come down and I'd see it taking 15 seconds and that's how they got that. Another determining factor if Eli was going to win that 75-yard race is if you just look at these lines. You can see Eli, his line keeps going up where hers is right here. So he's covering more yards per second. You can see on that graph as well. Okay, so explain how you figured out the answers to problems 7A and 7B. So here's an example, but you might have figured it out differently. Okay, so let me read through this example. When I extended Eli and Lupita's lines, I could see that Eli's line was above Lupita's, so I knew he would win. So that's what we just talked about right here. You can see his line is above Lupita's, so you know he's going to win. I could see that Eli's line reached 75 yards at 15 seconds. At 15 seconds, Lupita's line was only at 70 yards, so Eli would win the race in 15 seconds. So that would probably be the best answer for that. If you put something about how Eli gets 5 yards in 1 second when Lupita only gets 4 yards in 1 second, and did some math and try to solve it that way, that's fine too, as long as you were able to have a really good explanation. But this one is probably the easiest. Okay. So as always, if you have any questions or concerns, please feel free to email me. And otherwise, I look forward to seeing you on our next Google Meet.